So I decided to do a lifeguard web app for this project purely because I worked as a lifeguard for 10 years on various different beaches. I noticed that no matter what county council I worked for, the clerical aspects of the job were all done on paper. I just thought it'd be handier if we had a digital equivalent to use on the job. So I suppose moving on to the lifeguard use case. So the lifeguard use case has a directed, or the lifeguard has a directed association with the login use case indicating that the lifeguard initiates this use case. The login use case by itself is incomplete and requires the two included use cases, validate username and validate password, to be complete. The sign-up use case is an optional use case indicated by its extends relationship with login. The sign-up use case is only used by lifeguards who don't have an account. The home hub use case is incomplete without the login use case as indicated by its includes association. This indicates that a lifeguard must be logged in to access their home hub. The view weekly weather, view risk analysis, and view beach statistics use cases all have a bi-directional association with the home hub, indicating that you can navigate back and forth between them. So moving on now to the senior lifeguard use case. So we can see that the senior lifeguard actor is a generalization of the regular lifeguard actor, indicating that he can do everything a regular lifeguard can, plus he has these extra responsibilities represented by the use cases: create risk analysis, update risk analysis, fill in the daily report, and view the past reports. So moving on to the class diagram, I try to stick as closely to possible to the model view controller pattern. As we can see here, I have a main view object representing all my views. Possibly I was thinking maybe I should split this out into more than one class, but I think this will do fine for what we're trying to do. We'll notice here that we have the front controller object, which handles all input coming in from the main view. But we'll notice we have a one-to-one unidirectional association here, which indicates the main view doesn't know about the front controller, but the front controller knows about the main view. I went pretty heavy on the unidirectional relationships in this project, just purely to avoid pointer spaghetti. And we'll notice here as well that the front controller also has a unidirectional one-to-one association with the command factory, again indicating that the command factory knows nothing about the front controller, but the front controller knows about the command factory. The command factory again has a unidirectional one-to-one. That should be a one-to-one relationship with a command interface object. So it knows that a command type exists. It doesn't explicitly care which type of command. It just knows it's going to return some kind of command. So if we look here, we notice that all of these different command objects all realize this command interface, or in Java terms, implement it. Again, you'll notice that each these report commands, so the list reports command and the create report command, will have one-to-one unidirectional links. With a report service, which itself has a one-to-one unidirectional link with a report POJO. So a POJO is just a plain old Java object. So it's just a class with data and getters and setters. Again, the report service talks directly with a report DAO. So again, it's a one-to-one unidirectional. So the report DAO doesn't necessarily, well, it doesn't know anything about the report service, but the report service knows everything about the report DAO. I should mention this report DAO is an interface. So the report service doesn't actually care what kind of report data access object it gets, just once it's a report data access object. And we can see here that we have a report database data access object which implements or realizes this interface. And we can notice here as well that all the DAOs have a one-to-one unidirectional composition relationship with these connection objects, just to abstract away the connection aspects from the DAO. So that all the DAOs are responsible for are retrieving or updating data in the database. They don't have to know anything about connecting or closing connections. So if we move on to our sequence diagrams, here's the login sequence diagram. So we can see here that the lifeguard initiates this diagram off by invoking do post on the front controller. Once do post is invoked on the front controller, it invokes process request on itself, which goes and invokes the get instance method on the command factory, which we notice is actually a singleton class, so we can't have more than one command factory in the program. When the get instance returns, it then invokes the create command on the command factory, which goes off and instantiates login lifeguard command object. And then when that returns, we go down here and we invoke the execute method on the lifeguard command object, which then invokes the login method on the lifeguard service, which in turn invokes the retrieve lifeguard object on the lifeguard database DAO, which returns a lifeguard. And we fall all the way back again, so process request, and we forward this to JSP, and then after we forward to JSP, and then do post returns back to the lifeguard. So there's only one or two possibilities there. Either the lifeguard existed in the database, or he didn't, and if he did, he was logged in, and if he didn't, well, he was left in the login use case. So if I look at my create report use case, so we'll notice here that instead of it being a regular lifeguard, it's a senior lifeguard, as indicated in the senior lifeguard use case. Only senior lifeguards can create daily reports. So again, you notice the senior lifeguard will invoke the enter report method on the main view, which will invoke the do post method on the front controller, which will invoke the process request method on itself, which will invoke another get instance on the command factory, which again is a singleton class, which will invoke the create command, which will go off and instantiate a create report command object, which will then drop back to the front controller, which will then invoke the execute method on the create report command, which in turn will invoke create report on the report service, which will in turn invoke another create report method on the report database DAO, and we'll fall all the way back then to the front controller, which will finish the process request, will post back, and again enter report will post back to the senior lifeguard, who should get a notification saying that his report has been entered into the database. Again, here on the view past reports, so this should return a list of all the past data reports to the senior lifeguard. So again, we can see the main actor here is the senior lifeguard, who clicks view past reports and then invokes list reports on the main view, which invokes the do get method on the front controller. Again, it then processes its request and invokes the get instance method on the command factory, which again goes and gets an instance of the command factory, instantiates the command factory, which then calls the create command on itself, and this time goes off and instantiates a list reports command. So we can see the create command falls back here. We then go and invoke the execute method on the list reports command, which invokes the get all reports method on the report service, which invokes the retrieve all reports from the report database DAO. Again, we fall all the way back again to the front controller where process request ends, and again we do get ends and this report ends. So at that stage, the senior lifeguard should have a list of all the daily reports in front of them. So that's my project. I try to stick as closely to the model view controller pattern as possible. Hope I get a first for this. All right, bye bye.